Okay, modeling objects. So what we're doing today is just taking the volume formulas that we already know and applying it to real world situations. So instead of me just giving you this fake imaginary picture, I'm going to give you an apple. Can you tell me what shape an apple resembles? There you go. A sphere, good. What about, now, it can be more than one thing. What about a dumbbell? Ooh, good. The middle is a cylinder, right? The two weight parts will be hexagonal prisms. Some of you can't count on the quiz. The one at the bottom was a pentagonal prism, and a lot of you said hexagonal. Okay, there's 5 sides. What about, I don't know why it's so out of focus. What about the tent? Shh. What about the tent? Triangular prism. So it can be more than one thing. What about that silo? The bottom part is a cylinder. The top part is half of a sphere. Good. And we talked about this the other day. What about this house? Huh? Not a half a triangle. You're kind of right. This is going to be a close rectangular prism. Sorry, I just pushed rectangular on there. Because the base of a house is not always square. Like, could be. The top is going to be a triangular prism. Okay, so real world stuff is more than one thing put together. Which is why we take our time and do all our volume formulas first. Okay, so let's look at the next page. So, this is a human crash test dummy. We are going to approximate the volume of a human. Okay, so we're going to figure out the total volume. Don't forget the body parts where there are 2. So like there's 2 arms, 2 hands, 2 legs, 2 feet, that kind of stuff. So we're going to go through this and we're going to try and find the total volume of this guy. How much? Everything is in centimeters. So first of all, we have to decide what each part looks like. So his head, what shape do we think that is? A sphere. So it says there's a 17 centimeter. I need you focused. Otherwise I'm breaking you up. There's a 17 centimeter diameter for this crash test dummy's head. So I need the radius to do my volume formula. So what would the radius be? 8.5. So the volume is going to be pi 4/3 pi 8.5 cubed. I don't know how some of you were putting this in the calculator, but some people screwed it up like that. So 4/3 pi times 8.5 to the 3rd power. I'm going to write all the volumes over here because we're going to have to add them all at the end. So 2,572.44. Okay, we're going to stick with cubic centimeters for now. His neck. What do you think his neck is? What shape?
But not a sphere. Cylinder.
There you go. A cylinder. The height is 8.7 centimeters. 8 centimeter diameter. So our radius here is 4. So we're going to do pi 4 squared times 8.7. So pi so 437.31. There's a reason we're finding the volume of this human being. So it's torso. That's this part. What do you think? What shape? Let's pretend it's not a cylinder. It's not a triangle. It's not a square. There we go. Rectangular prism. The person that said trapezoidal prism would probably make more sense, but we don't do trapezoids in this class.
Why?
Because. So, it gave its width, its height, and its depth. We're just going to multiply 41.5, 59.6, 17.7. Anytime you have a rectangular prism, you just multiply all three numbers. So 41.5, 59.6, 17.7. So 43,779.18. Okay. His arm. Whoa. What shape do you think his arm is from here to here? A cylinder again? Now we have to be careful because how many arms does everybody have? 2. So we're going to take our volume and we're going to have to multiply it by 2. Again, it gives the diameter because we can only measure diameter. So the radius here is 4.05. No, you don't. So I'm going to do pi 4.05 squared times 57.5, but I'm going to multiply it by 2 because there's 2 arms. Okay, so I'm multiplying it by 2. So pi 4.05 squared times 57.5 times 2. 5925.95. Okay, the hand, to find the volume of a hand, we're going to assume it becomes a fist. So what shape would a fist be? Sphere. Could be a cylinder, but we're going to pretend it's a sphere. Remember, it's just kind of an approximation. Okay. So I have to cut the 7.5 in half to get the radius. 3.75. Now I'm going to do 4/3 pi 3.75 cubed. But how many hands do you hope people have? 2. So I got to multiply it by 2. Because there's 2 here. So 4/3 pi 3.75 cubed. 441.79. Okay, his pelvis is this part. Again, it was probably more of a trapezoid. We're just going to say a triangular prism. Now, here's where people screwed up last time on the quiz. when it's a triangular prism, we're going to multiply all three things, but I have to cut it in half because it's a triangle. So some of you on the quiz didn't cut it in half because it was a triangle. $4914.85. Look at his legs. What shape do you think his legs are? Good. And how many legs does he have? Ha. So again, we got to find the radius. 6.15. So it'll be pi 6.15 squared times 76.1, but we got to double it because there's two legs. You guys did do very well yesterday about showing all your work, even though those of you who don't like to. So 18,084.84. Okay, last one is feet. What do you think his feet are? Nope. What? No, close. It's a prism. Yeah. You said cylinder. Oh, I didn't hear that. I heard cylinder. So 9, 26.3, 9.6, but how many feet do we have? 2. So we're going to multiply it by 2. So 4,544.64. So we're going to add up all of the total volumes and get a total for the whole crash test dummy. Here's the total. So the total for the whole crash test dummy is 80,701 cubic centimeters. So that's how much our crash test dummy is. We're going to take that and we're going to do something with it on the next page. So on the next page, we have, it says a couple years ago, the Club Fit team of Australia attempted to break the Guinness Book of World Records for the most people to fit inside a smart car. So we're going to watch a video of their attempt. So they crammed 18 people in that car. Let's take our crash test dummy. If I say the approximate volume of a smart car is 57.4 cubic feet, for our approximation for the human, how many people do you think we could fit inside the smart car? So we're gonna have to convert some things first, because our crash test dummy is in cubic centimeters and the volume of the car is in cubic feet. So we gotta actually convert our conversion before we can do anything. So if we have 1 foot is equal to 30.48 centimeters. To get it to cubic feet and cubic centimeters, the conversion, I'm just going to cube both sides. So I'm going to take 1 cubed and this guy cubed. So 1 cubed is just 1. 30.48 cubed is 28,316.85. Sorry, I smushed that in there. So if we take our volume, let's take our crash test dummy and convert him from cubic centimeters to cubic feet. So we're going to take our 80,701 cubic centimeter crash test dummy. I'm going to divide him by this to get how many cubic feet he is. So divided by 28,316.85. Because the cubic centimeters will cancel. And then you'll have how many feet he is. So 2.85. So each person is 2.85 cubic feet. So to figure out how many people we could fit into the car, I'm going to take the 57.4, I'm going to divide it by the 2.85. So 57.4 divided by 2.85. This says we should be able to fit about 20. It says 20.414, but you can't have 0.14 of a person. So we're going to round down. It says we should be able to fit 20 people.
That's what they said.
They only fit 18 because you still have space, right? It's not like people can perfectly fit. So that's why it's a little bit less than normal. So this is all we're doing this week, today and tomorrow, is taking stuff we already know how to do, like finding the volume, and making sure it works, figuring out how it works in the real world. Okay? So if you are still struggling with the volume formulas, you basically have 4 more days of review. Questions?